Okay. Hi, everyone. So in today's lecture, we're going to talk about interaction with the user. And what we will be talking about is basically how we can make a mobile app easily accessible for the user, no matter which device they use. Um, so I changed how the structure or the schedule would be for the class. I was planning to, this week, we were going to talk about Kotlin. So we could get started with the programming, but then I realized that the homework too was about creating user interfaces. And so I decided to swap these two around so that at least you have a sense of how to design an interface before you actually do the homework too. So when we create an app, the first question you need to ask yourself is, in which device is the user going to be interacting with your application? And so how will the user experience your application? Is it going to be just a single device, or do you have multiple devices? And most applications only consider one device. But we have certain applications, for example, Spotify, where you can start using the application in your phone and enjoy it in your TV, for example, or Google Home on your speakers, or even on your desktop if you use the browser or the mobile application from Spotify. You can actually control which track you're listening to, increase and lower the volume, all of those without necessarily being the device that you currently have and you're using um, playing the songs. And so when you think about this, there are two fundamental ways that the user is going to interact with the application. So what devices are going to be that they're going to use, and how they will be interacting with the device will depend on what is supported by the device as input and output. By input and output, I mean how the user provides instructions or actions, and how does the system communicate what the user attempted to accomplish, which is increasing the volume or lowering the volume or changing tracks and things like that. We are mostly familiar with touch interface or touch interaction as input, but there's also voice, and you can also use gestures. You can use sound, vibration, so haptics, pressure, and others, like, for example, bending or heat, in order to input or output something from your application. And so here's an example of Mercedes-Benz interface on the car. And so when you see this video, I want you to think about how does the system keep the driver informed? How does the system support hands-free interaction with the car? And what happens in the system when it's too loud that the system can't hear you talk, for example? So I'll play this video, and I want you to think about these three things, and we'll discuss this a little bit after the video is over, okay? Okay, so as you could see from the video, the system uses both voice as also visual feedback for the user so that he can know what's going on based on the commands that the user has given. The other thing that you probably notice is that the device actually lowers the volume every time he speaks to him, every time it detects the keyword. But there was also on the actual steering wheel, there was a button where the user could press where they could actually trigger the voice recognition and also allow them to select items from the menus without even touching the screen. And so this would mean that the user could either use voice or just use your thumb in your steering wheel in order to select an item and action of what you need. So this is a good example of how when you create something, you could account for more than just one modality for input and allow the user that way experience your app without necessarily just relying on touch. So I've been talking about multimodal interaction. So if we were talking about visual interaction, this means that it would require your eyes to make a decision. Auditory requires your ears, so you need to listen in order to understand what's going on. Haptic requires actual physical touch. So things like a vibration in your wrist if you have a smartwatch. And then, of course, touch if you have a smart display that would recognize gestures, for example, or touch input. And so the biggest challenge that we have is in mobile computing is that how do you create an application that could be experienced and used when you cannot have access to some of these modalities? So for example, if you can't see because it's dark, so you need to light up the screen, like what you do. What if you can't hear? So let's say you made an application where you should, let's say, take a picture just using, okay, take a picture using your voice, but then you're in a noisy environment, then you can't use it anymore. So you should have a button somewhere that would allow you to manually do this. Or let's say that you're using the Google Home Hub, for example, which is a public display kind of interface, and you're cooking and you can't touch the screen to select an item. So your hands are wet, for example. In this way, for example, if you're cooking, you could just say, okay, next instruction, or play next music, or play something from YouTube without even touching the screen. And so using voice is a good modality in this case. So when we think about the thought process to come up with these modalities, which we could consider things like, is the user in motion? So for example, if you're making an app for sports tracking, you probably should think about how you're going to keep the user informed from your app, maybe using the headphones. And so you have your app talking to the user, what's going on. And this way, the user could interact with your app without actually needing to take his phone out of his pocket and deciding to act on your application. The other thing that you should consider is that, for example, if you're using voice or sound as an output, is whether or not the information you're going to be providing is private, or can it be shared with someone else? So this is not just audio, but also visually. I mean, if you have a display that is a public display, so like the Google Home Hub, then maybe the information you're going to present to the user won't be the same that you would present to someone else. So I can give you a very concrete example of this. So I do have a Google Home Hub at home, and whenever I ask Google Home Hub to show me my calendar events, it only recognizes my voice and then it shows me my own events. And if it's my wife asking the same question, it recognizes that it's her. But when it doesn't detect or recognize either one of us, then the system actually knows that and it doesn't show anything. The other thing that you can also consider is like, how close are you going to be to the device? Can you touch it? Can you read what's on the display? And then the other thing is, for example, how do you know How do you let the user know that you want his attention? So when something is happening and you require the user's attention and input, like how do you let them know? Traditionally, smartphone applications use notifications for this effect, but you could think about vibration, you could think about turning on the screen, for example, or playing a sound to get the user's attention. So a notification, in a sense, is playing a sound, but you also have the visual cue that you have something waiting. Um, and then the other thing is, how do you deal with typing? Is there a keyboard, or do you do voice recognition? You don't necessarily have a keyboard, for example, on a smartwatch or in the car or on your TV. So thinking about how can you use your application without necessarily depending on touch or a keyboard is an interesting thought process that you can go through in order to increase the modality support that your app offers. Here's a device that has been in Indiegogo or Kickstarter, and it's a multimodal device that kind of pushes a bit outside of the box on what you could do beyond what you normally have on the smartphone. So we have multimodal device that is both visual, so you are presented with information on the screen, auditory, so you can actually talk and listen to the phone calls. It has haptics, so it vibrates to know that it's ringing, and also touch, where you can touch the screen and the buttons in order to interact with the device. So here it is. So that was one interesting take on creating a novel device that would take into account more than what you can do right now with your smartphone. So you can charge it, and it has a double function where it actually acts as a smartwatch, as well as a phone, location, activity tracker, so many things into one device. So I mentioned input and output. So input are commands that the user provides for the system. And this input can also be provided by the user, but it could also come from another device. So in the example I gave before in terms of Spotify, where you have one other device giving instructions to your smart speaker or your phone to increase and lower the volume, that comes from another device and not necessarily from the user. And output are the actions taken by the system. So normally the output that we are used to is more visual. And normally these show the result of the input so that the user and other devices can understand what the user wants to accomplish. So if we think about examples of input and output commands and actions, we have things like touch, speech, action like gestures, eyes, ears, other databases, other devices. Location is a good input. For example, Google Maps does not work without the input of your location sensor, so that it works as the output to tell you where to go. Time, for example, time is a good input sensor, for example, for your alarm clock. You won't know when to trigger your alarm unless you know the time. And light, for example, to make your phone adjust the brightness of the screen depending on the amount of light you have around you. Vibration, keyboard, for example, even your car can be input and output. So if you use Android Auto, this is one example where you have input from the user, and then the output is what you have on your radio. And each one of these can be more granular. So for example, if you look at touch, so fingers input can be a tap, a double tap, for example, long press, swipe up, swipe down, swipe right, left, pinching, zooming out, or rotation, for example. And then if we think about, for example, other means of input beyond the touchscreen. So if you think about, for example, Huawei's smartwatch gestures, it actually extends to the bezel of the smartwatch, where actually rotating the bezel towards one side or the other would actually zoom in or zoom out, clicking or pressure would trigger different actions so that you actually don't need to interact with the screen itself, leaving fingerprints on it and protecting it from scratches, for example. And you would just use the bezel for performing the same actions that you would traditionally do just using the touchpad. So the other thing that we will talk today is how text. So if we think about the visual output, so text also plays a very big role in when you create an application, given that we have displays all over the place, and your smartwatch and your smartphone also rely on text in order to inform the user. So given the widespread of different density pixels and density resolutions on your screens, nowadays the scale of each font actually is going to adapt depending on how much screen estate you actually have available for you, and not necessarily based on how many pixels are going to be needed to draw a single shape or single letter. And the reason for that is because this way, if you do a scalable pixel as a measurement for specifying the size of the font, it will adjust automatically based on how much space you have, and the design is going to look exactly the same no matter how more the density pixel intensive is a display. So a retina display, for example, has a very high amount of pixels in a specific area of your display. So then if you just use the number of pixels to designate how big is the text, then if you open that on a retina display, everything will look really tiny. So the other thing that is important about typography is what kind of message does it communicate. So if we look at these pictures on the left, so which of these two designs would we pick? So I would say it depends. So if we have something more personal, emphasis on the who it is, you probably don't need the last name of the person. and then you would choose the left side. But then if you want something more professional, more impersonal, and more emphasis on what is it that you're trying to do, so in this case, just have a contact information, then you would prefer the second one. So when you're making an application, you need to think about what kind of end user is going to be for your application. So we gave this example in class where people took a piece of paper and they wrote their name. What happened is that every name was different. Everyone wrote it in a different way. Some people made it really tiny, which made it impossible for me to see what their name was. And basically, what I wanted to show is that the reason for that is because we didn't agree what were the requirements, and we didn't even discuss what was the paper going to be used for. And so this way, I just wanted to highlight that in many ways, when you're working on your team and doing the project later, if you don't all share the same guidelines, you end up having difficulties coordinating your work together, especially designing the application. So the Google, in order to kind of solve this issue amongst their own teams, they actually created what we call material design, which is a design framework. And they have been using this design framework to creating all of their apps on the recent versions of Android. And the new apps themselves use material design. So what is material design? So material.io is a website where Google has basically documented their thought process into creating this design framework. And it's a way of thinking of design in a way that every single item is physically in front of you. So if you think about two pieces of paper, and if you want to put them together, either you put them one on top of the other, or behind it, or side by side, but you can't like merge them together like this, right? And so material design thinks about the software UI elements in space. And so this would be X, Y, and Z axes, and normally the thickness of these devices, these items is 1 density pixel. So let me show you how that looks like. So if we have this application, for example, on the right, and if we would put it facing like this, this would mean that you would have a stack of software or UI elements that are on top of each other, and they make you the UI, and you can interact with it. And if you can see, for example, here, you have a deck of cards where they're all stacked on top of each other, and you have this visual cue that there's more to it behind, like below it. You have these shadows here that shows you that, okay, this one is in front of that one, and in front of that one, and so forth. So the other side of design is the icons you pick. So Google has actually have instructions on how you can create a very nice icon for your application. This website here, the Noun Project, has a very good search engine where you can find ideas for icons, and you can actually download them if you want. And also there's a tool in GitHub created by Google where you can actually use it to generate icons for your app. So where you can actually take one of these icons from the noun project and drag it into the tool they have, and you will create an icon that is material design-ish for your application. So this is how you create a material design-oriented icon for your app. Okay, so after you decided how your icon is going to be to identify and brand your application, you also need to think about the colors. And so material design is a bit, I would say, adventurous in terms of what kind of colors you use. And so they have this philosophy that there's no wrong color. And they actually have a tool for you, a color tool in the material design, so material.io website that you can use to generate a set of colors that go well with each other, and then you can use that to inform your design when you're creating an application. So here's an example of that. Yeah, so if you're not sure about which color to combine, I would just go to material.io, and there's a color tool in there that you can use where you can play around with colors and decide how it's going to look like. So if I show you that, Just a second. So if you go to material.io, then you should be able to search here color tool. And in here, you can create what your app is going to look like. So you can pick a color from the palette and see how it would look like on the UI. So if you want to say light blues, for example, for your color, so we would press there, and it would actually show you how that should be considered, so that your primary color will be this code, and this is your secondary color. So if we choose the secondary color, let's say pink, it will highlight these here. And then if we want to choose the color of the text, you can say, for example, I want my color to be green. So that will look like that. And let's say this color here would be orange. And so that highlights there. And then when you choose these, it actually gives you a ranking of how well do these colors work for you. So if you want to see how this looks like in different items here, you can choose here, and it will shows you, give examples of how this set of colors would look like in here. But it will also tell you like how accessible is this color scheme for you. So if you press here, you can see, okay, my custom text is not very legible. My white text is not very legible in here. And so you can tweak these in so that it would increase the likelihood of your application to be more usable for someone that has, for example, color blindness. Or the font size is too small. So you could think about how you could combine these in order to make it better. So we can also reset this so it goes back to everything. It's interesting that black and white seems to be okay. But we can also choose here a set of colors based on this diagram in here. Ideally, you should stick to the material palette. So these are standardized colors, and that makes it easy for you to create an app quite easily. So you can think about how you would combine these things together. You can tweak any of these, okay? So that's an example of this tool. So back to our presentation here. Yeah, so once you decide the color you're going to use, then you need to think about how you're going to display your items visually so that it would minimize errors. So if you think about margins and paddings between elements, it's not necessarily for cosmetics, but it's actually for accessibility of the interface. In general, because your screen is so small compared to, let's say, my monitor or your computer, you should keep your text succinct and clear, like straight to the point, don't babble. And this way, keep the user informed why you're sharing this content to them. The other thing that you will notice is that positive actions are always positioned on the right. So if you see here, the agree button is actually on the right side, and then the disagree button is on the left side. Why is that? The reason for that is because we want to make sure that it's easy for the user to accept something or to agree with something than it is to disagree. For example, we really want to make sure that the user, when they cancel something, that's really what they want. And so that's why, in general, the guideline here is to have positive actions always positioned on the right. The other thing is, don't be afraid of white space. Use it to kind of frame your content and to also make sure that the user knows where he needs to look at and what is important. So if you push this further, the average size of someone's finger is about 48 density pixels. And that means that when you create an icon, like for example here, you have 48 density pixels wide, and then the icon itself is 40 pixels. But then you have a buffer there so that if the user taps here, you won't be able to interact with something next to it. So for example, between these two icons here, if you press the heart shape and you press the search uh, the our magnifying glass icon, there's a little chance that the user will interact with the wrong icon or with the wrong functionality. And this applies to pretty much all the items that you have on on your interface. So there are various amounts of UI components that you can use and cherry pick. So there's a link right here that you can use to see like a gallery of all the components that you can use to make your application interface. So you have bottom navigation, you have floating buttons, you have cards, you have dialogues, expandable views, grids, sliders, and many more. And so you should choose those that make sense for your app and the interaction that you want to accomplish or the task you want to accomplish in your app. You can also create them from scratch, but of course that is a bit more challenging, but it might be necessary if you have some use case that is really specific for your application. So let's switch gears a bit. So let's talk about, so we talked about the application itself. Let's talk about like what runs behind the scenes. So what makes an Android app, for example, what are the building blocks of an Android app and how do these like interfaces fit into? So we normally have, these are the most important components for Android. So we have activities, and so activities is the space, is where you actually implement what happens on the interface. So this is what the user perceives to be your application. This is what the user sees. And so this activity is where you program what happens when you press a button, what happens when you scroll, what happens when you swipe, what happens when you zoom in or zoom out, and things like that. A service is a background job. So basically these are things that can happen behind the scenes, things like going online, retrieving the latest content, and bringing that into your app, for example. An intent. So what is an intent? So an intent is how on Android, two apps can talk to each other, and also the operating system and also the app itself between different components of the application. So when you go from one interface to another interface, you use an intent for that. So basically you tell the operating system that you're done with this interface and you want to load another interface, or you want to start some syncing event. So you send an intent where you say, okay, I need you to retrieve this information from the cloud or send this data that I just recorded to the cloud. Broadcast receivers is basically a listener, a piece of code that basically waits for things to happen. And these can be things that are triggered by DOS. So for example, turning off the screen, or rebooting, or closing the application, to things like receiving a command from another application to use some functionality that you have implemented inside your app. There's a small thing that we need to be careful here is that when you create a broadcast receiver, whatever they have to do needs to be done within 15 seconds. And that's just a rule, because if you don't, your application will crash, and we don't want that. So these are the ANR errors. So this means Android not responding. So what Android will think is that your app has jammed and you will kill your app. And you want to avoid that at all costs. A provider is a database, and this database can be either locally or remotely. But traditionally, most applications are offline first, so they will try to keep as much possible data locally on the device so that you can actually use the app without necessarily needing internet to use it. And the lastly, but not the least, the manifest is where you have a map of all your application's components so that Android itself knows what is your app made of. So you have your activities, you have your services, you have your broadcast receivers, you have your providers, you have your intents. All of those go into the manifest. If they're not there, Android does not know what is it that your app supports. So let's talk about activities. So activities, like I said, is the space that guides the task that the user can perform. And this is what the users perceive as your application. So if you think about an activity, it has different states. So when you first launch your application, it will call this method called onCreate. And this is where your application is initialized. It will find, it will read your how you define the interface, and it will add the actions to all the buttons and all the logic that goes in there. And then it goes into the onStarted event, which is it's visible to the user. The user can start acting on your application. Um, so if the user, for example, turns off the screen and your app was running, it will go into a state of paused. And this means that your app is still running, but the application is paused because it's still running on the background. And if the user turns on the screen, for example, or another example could be instead of turning off the screen, they could go to the home, to the launcher, but your app was still running on the background. Then when you come back to the app, you get the on resume, the resumed state. And so the user comes back to your app. And if the user presses the back button or leaves your app completely, you go to this on stopped state. And then after a while, or if the user clears it from the list of running applications, it will call the on this right method. So why are we talking about these states? So if you think about your application, what the activity can do, it's how the user perceives your application. So when you open the application for the first time, you probably want to do things like a splash screen and then show the user a list of things, right? Or a map or something. But then let's say you have your user, providing some new item. Let's say a to-do list where you're adding a new item in there, but the user did not press the save button. And the user was interrupted for some reason and closed the screen. And then when they come back, you probably don't want the user to start over and lose all of that effort that he had done to create the task on the first place. So you need to use these states so that you can save in memory or save locally what was the progress the user had done, and then resume from there. So how do you create a layout? Like how do you create an interface? So there are different layouts that you can use. So this is one example. So a frame layout allows you to have a visual element on top of another. So it actually allows you to stack different elements together. There's another one, for example, that allows you to organize the content either horizontally or vertically. The vertical linear layout is actually quite useful, especially if you have a smartphone application where you have a list of things that the user needs to scroll over. But the horizontal orientation, for example, might be more handful for tablets, for example, because they are landscape oriented and you need to put items one by one. The other thing about this layout is that the elements don't overlap. So if you add, let's say, a text box and then you add a button, they will be side by side, not on top of each other. The relative layout is a bit different. So the relative layout allows you to define rules in which items will be positioned in the display. So for example, if you have here the button 1, it says here align to the parent, true. So this will align on the outside display that you have in here. And if you have, for example, the button 3, it says it's on the right of button 2 and below button 1. So that this is the only position that this would fit in where it doesn't overlap. So none of these overlap either. And so, for example, if we have button 6, it says here, okay, center horizontally and vertically. And button 7, for example, it says align parent to the bottom. And so this, no matter what orientation you have your phone, so whether it's landscape or portrait, it will actually always keep that button at the bottom of the screen. So you can think about this like this. Grid layouts are a bit more flexible in which they resize the items in order to accommodate your rules. And so these, then they don't have width or height. So they actually wrap up their content and scale them up so that um, when you have multiple items, so for example, pictures, where you have pictures that are 16 by 9 or 4 by 3 aspect ratios, you would make them fit nicely next to each other so they would occupy the whole space that you have on your display, where you don't need to worry about a positioning. Okay, I want this on the right, on the left, or anything. You would just fill the whole space you have with as many items as you have, and you will scale them so that it would look as optimal as possible. So there's a different kind of layout, and this was introduced very recently. It's called the constraint layout, and this is a recommended way of doing interfaces nowadays. So the constraint layout is based on rules, so it's relatively simple, similar to the relative layout, but it's a bit more flexible in the sense that it doesn't deal with margins and paddings and things like that, like the other one, and it just deals with semantic rules across the items, like which one is on the right, which one is on the left, is it aligned to the top or to the bottom. And the good thing about this, it's most of it is just drag and drop, and you don't need to make your interface too complicated. And you might have to do some minor tweaks in code if you really need to make something not standard. But I would suggest you use the UI designer of Android Studio so that you get the most up-to-date and the most flexible interface that you can do just by drag and drop. Here's an example of how you can use this in practice. Yeah, so if you want my recommendation, I would just use constraint layout for your application. It makes it so much easier to create a custom UI by drag and drop. What layout the constraint layout also allows you to do is to actually animate your interface. So you can actually create a before and after state of how your interface is going to look like. So you get this transition between A to B. So I have this video here that I didn't actually show in the class, but you can actually see it in the slides. So you can see an example of how you can animate your interface, where you have the initial state of how the interface is, and then how it's going to animate too. And the animation is actually done automatically for you. And this is a very easy way of making engaging interfaces. I wouldn't show it to you now because simply there's code in there that I still haven't told you about, so it will just make it harder for you. But I would just say that once we know how to make these interfaces, you can definitely come here and see how you could animate your application. So let's talk about services. So a service is a task that happens on the background. And so similar to the activities, the service also has a life cycle. So we can start a service with start service, and then it goes to the on create, on start, the service is running. And then when the service is done, it can call the on destroy, and it turns it off and releases the resources from your phone. So a service can either be long lasting, so it's always running, and you can call it multiple times by sending a new intent saying that I need to do this now, and it will just do that. Or if you want to do a task that will automatically destroy and will relieve the resources once the job is completed, you use an intent service, which is a lightweight version of the long-lasting background service. And the other thing that the intent service allows you to do is that you can actually queue them. So you can say, download pictures from A to B one by one. And this way, you don't need to worry about dealing with a whole set of things. You can just do a picture at a time, and if you call the intent service with picture A, B, C, D, it will just do A, wait until A is done, and then bundle B, and so forth. So I've been talking about intents. So intents is the communication channel between the application and the OS, and also between the components of the application. So if we think about starting an activity, so showing an interface, you do start activity and then the intent. If you want to run a background service or an intent service, you do start service and then the intent. If you want to send a broadcast to the operating system, you do send broadcast intent with what you want. So the intents normally have what we call an action and extras. So an action is literally a string that describes what you want to do. And so this would be, let's say, change for the next track if you're interacting with the music player. And the extras would be, for example, which artist you want to play or which track you want to play. And these are just parameters. So you could think about key value kind of thing. So artist equals Lady Gaga, for example. So the broadcast receivers, like I said, these are units of code in your app that can either react to other apps, or it can also react to things you want to accomplish within your app. And you can define them in two ways. One of them can be in the manifest directly, where you specify, for example, you want your app to react whenever the phone has finished booting up for the first time. So if they rebooted it and you want your app to run, you can define that on the manifest. And so this way you could resume your app from running, even if you turn off your phone and then your phone dies and you just turn it on. So you can think about an example of this. So how does Facebook and WhatsApp resume working if you reboot your phone? and then as soon as you get back to using your phone or you have battery again, Facebook and WhatsApp allows you to receive messages and notifications all automatically. And so what they're doing is literally listening for this OS-oriented broadcast saying that the boot has finished, and then resume operations. The other way is to actually have a broadcast receiver implemented in your actual application. And this would mean that your app would only react to this if the application is running. And so this would mean that, for example, it doesn't make sense for your app to receive events. Let's say you're making a music player and you only want the user to be able to interact with your app whenever your app is actually running. So this would come into play in this case. Similar to the intents, the receivers also have actions and extras. So the action is just a string that describes what you want to accomplish. And the extras is just a set of parameters that you can pass. So you can think about things like authenticate the user into your app. So the action would be to authenticate, and the extras would be your username and password. I already mentioned this, so a manifest and a runtime broadcast receiver. So if you do it in runtime, so in code, it would only react if your app is running. If you do it in the manifest, it will react to the broadcast even if your app is not running. So Android 8, Google has set a specific limited amount of system-specific broadcasts. So things like the boot completed, volume up, and things like that. These are okay, but then things like creating a contact and things and other system-based broadcasts, they started to block them because applications were exploiting these intents in order to harvest data, personal data, from someone else's phone, even though you would not be actually using this app. So you could think about like malicious games that you would install on your phone, and then basically this game would be collecting every time you make a phone call, every time you receive a text, and things like that without you even noticing that that was happening. So providers are databases, and typically these are locally to the application. In this class, we're going to use Room. So Room is an engine that wraps around content providers, which is the old style of making databases on Android, and these were really complicated to do. But with the new engine, it's actually quite trivial to make a database to store data. And normally the database, when you implement a database to store data, it follows what we call the CRUD architecture, so create, read, update, and delete. So these are the 4 functionalities that your database should support in order to allow the user full control of his data. So adding new data, reading existing data, updating existing data, and deleting existing data. For the class assignment, we will be implementing a database using Room, where you will have these methods implemented. And so, like I said, the manifest is a map of all the components of your app. And you have things like which permissions do you need to access the sensors you have, whether that is the camera or the microphone or the internet or storage and all of these. So these need to be declared on the manifest. An activity is where you input all the interfaces that the user is going to have inside your application. And there's a very special one here, which is this main and launcher intent and category. And so this activity with this intent, basically what it does is it tells the operating system that I want an icon for my application to be visible on the launcher. So if you create an application without this, you actually won't see it when you install it on your phone. So you really need at least one activity that has these two, this intent filter defined. Then services are also here, and as well as providers, they should be here. So that was it for this class. So tomorrow in the labs, we will be building interfaces using Android Studio. So we're going to use what you learned in terms of material design and the paddings and the typography so that you can create the most compelling application as an assistant reminder for the first half and then for your project later. I hope you enjoyed it, and I'll see you next class.